Since Hannibal and his army of elephants, there have been hundreds of attempts to cross the Swiss Alps, but none as ambitious as this one. When it's finished, the Gotthard base tunnel will be the longest and deepest in the world, 35 miles long and 8,000 feet below the highest peaks. But it won't be finished for a while. They've been digging for 10 years, and they've got another 10 to go. They're almost at the halfway point, but not quite, and they're running into trouble. There are lots of tunnels through the Alps, so what's different about this one? Most mountain tunnels start at altitude. The Gotthard base tunnel runs through the base of the mountains. The pressure from above is far greater, squeezing down on the tunnel, making the job of the engineers much harder, and the work of the miners more dangerous. For 2,000 men working 24 hours a day, it's a tough challenge. Matthias Neinschwander, chief engineer, is responsible for the largest site and a $1 billion investment. Since the age of 18, he's worked underground all over the world. He's a tunnel rat. He's only 33 years old, but young gun David Fabry is already one of the project's leading troubleshooters. If something goes wrong, he's the man who has to put it right, and fast. Top tunneling engineer Albert Schmidt has to make sure the tunnel won't collapse. He's working a section with the worst geology and fighting a constant battle to hold back the mountain. The lives of thousands of future passengers are in his hands. The Gotthard is the toughest and longest job any of them have ever worked on.
I've never been bored one single day in my job here because it's interesting, it's fascinating.
This rail tunnel will join northern and southern Switzerland, cutting a passage directly beneath the Alps. It'll create a new route that will allow high-speed trains to travel from Zurich to Milan in 2.5 hours. The Gotthard Massif is an enormous pile of rock. Today, the only way to cross it is on heavily congested roads or on a punishingly slow train. Freight vehicles crowd Alpine highways, and every year the jams are longer. Switzerland's clean air and beautiful landscapes draw millions of tourists every year. But pollution is on the rise. The new tunnel promises to ease traffic congestion and reduce pollution. It'll cut the journey time through the Alps to 13 minutes. Freight will go by rail and the roads will flow freely. But the Alps are a geological monster, and drilling through them isn't going to be easy. Albert Schmidt has been battling some of the toughest rock conditions over the last few years.
We have different kind of rock conditions. We have quite hard rock conditions, a good rock on the right side, and we have soft rock, destroyed rock on the left side.
Hard rock is relatively easy to tunnel through, but soft rock is a nightmare.
On this side we have just very poor rock conditions.
The Gotthard is running deeper than any other transport tunnel in the world. In some places, the tunnel has over 8,000 feet of rock above it.
There are millions of tons that are pushing, that are weighing on this structure. And when we take out all this material, all this rock, this huge amount of rock out of the mountain itself has to make a reaction.
And it did react. 4 miles in, the mountain collapsed onto one of the project's enormous tunnel drilling machines. It's stuck, and there's no reverse gear. Beneath the Swiss Alps, construction continues on the longest tunnel in the world, all 35 miles of it. With 5 sites and a combined workforce of 2,000 men, this is the largest construction site in Europe. One tunneling machine is stuck and needs rescuing. But they're drilling 2 parallel tunnels, and in the other tunnel, the work goes on. It's dawn, and on a project that never sleeps, a shift is preparing to make the journey to the tunnel face.
È un'emozione lavorare a un progetto così grande.
Se era venerdì ci sentivamo bene.
Io che sono vicino alle 6.
Tu alle 4:30, lui alle 6, che ingiustizia.
Abitate in mare.
Ho detto ogni giorno è sempre diverso dall'altro. Non può essere sempre lo stesso.
Their shift starts with an hour-long, deafeningly loud, bone-shaking journey just to get to the tunnel face. Small trains take them 8 miles into the mountain, where they take over the boring machine that's still working. The train lines stop where the machine begins. The men will spend their 8-hour shift inside this amazing contraption. The tunnel boring machines specially built for the Gotthard are the biggest land vehicles in the world. Each one cost almost $23 million. Built in Germany, they had to be shipped to Switzerland, and as they're so gigantic, they had to be moved in sections. Once on site, each piece was shifted into the tunnel by train and assembled underground. Once it's up and running, the hydraulic arms push out sideways against the tunnel walls to give the machine enough leverage to push forward against the rock face. The turning action combined with the pressure crumbles the rock. And there you have it. A fully operational boring machine the length of 4 football fields. And it won't see the light of day for nearly 10 years. In each shift, about 25 men work on Gabby 1. But the men who work here at the cutting heads have the hardest job of all. When the machine is in motion, it rattles violently. They spend 8 hours on a platform that shakes like an earthquake, attaching meshing to the tunnel roof to make it safe from rock falls. It's a dangerous job. If any rocks fall before they shore them up, they're the ones who get hurt. Where the rock isn't firm, they also have to drill in long steel rods or anchors, which help stabilize the roof. They use water to cool the drilling heads, which quickly become hot. Each day, the machine advances by up to 32 yards. It picks up its enormous feet and pulls its 400-yard-long body further down the tunnel. And it takes a whole lot of energy to keep it going.
A long tunnel like this needs a lot of supplies just to get the machine going. We need to take out every single day about 7,000 tons of rock of the 2 tunnels. We need to get into the tunnel about 2,000 tons of concrete poured and sprayed. We need about 2 million liters of water to get the machines going. And of course, we need ventilation, we need a lot of power, we need each and every of those two machines takes about the amount of power it takes to run a small town of 20,000 people.
With workshops for electricians and mechanics, the machine is a constant hive of activity. Because of the vibration, parts are constantly breaking. The machine is stuck down here for years, so each shift has a crew of electricians and mechanics who fix it as they go.
Here, look at these two rings. We alter them because the way they are produced directly at the factory can't stand the vibrations. I finally designed this way of doing it with the rubber, so that they don't break as much.
But not everything can be fixed this easily. Only 40 yards away from Gabby 1's tunnel, boring machine Gabby 2 has been stuck for the past 2 months. The Gotthard project involves digging 2 tunnels, one for northbound trains, the other for southbound ones. Gabby 1 is here, making a steady advance, whilst Gabby 2 is stuck in the parallel tunnel. 2 more boring machines are making the attack from the other side of the mountain. Eventually, they'll meet in the middle. Engineer Stefan Muff is traveling to check on the progress of Gabby 2's rescue operation. All previous attempts to set the boring machine free have failed. So far, they've been fighting a losing battle.
The tunnel boring machine got stuck because right here the mountains have been worn away by water. It was hard granite, and over millions of years, water was flowing through, which transformed the hard rock into a crumbly sandstone. And when we entered with the machine, the material came down like an hourglass. And to make matters worse, we had water, and it flooded, and it looked like a huge river had gone through the machine.
Mountain streams and fresh alpine water are beautiful above ground. But below ground, it's a different matter. In the tunnels, water spells danger. When the rock face collapsed, the machine was trapped. To rescue it, Stefan's team are blasting an access tunnel to the drilling head, where they'll clear the broken rock.
The tunnel over there is the one that we will use to attack the bore head directly from the front.
This is the access tunnel. After each blast, Stefan's team clears out the loose material, spraying water to reduce the dust. He's still worried that the rockfall at the head of the machine could collapse on the rescue team. So they're also blasting another tunnel to the side of the trapped monster. From this tunnel, they'll inject concrete into the crumbling mass of rock so that it's solid and safe when the team breaks through at the front. They're not sure it'll work, but it's their best shot. With one machine jammed, they need to keep on trucking in the other tunnel if they're to stay on schedule. But a rock face collapse could happen here too. 6 hours out of every 24, there's the maintenance shift, and the machine's out of action. That's when geologist Beat Fry springs into action. His job is to collect samples of the rock ahead, discovering if it's unstable or soft, so that he can warn the drilling teams to go cautiously. Since Gabby 2 was caught by its rockfall, everyone's afraid that the same could happen to Gabby 1. Maintenance investigations are crucial. Without them, they literally can't go on.
The aim is to spot the areas where the rock is weaker, where problems might arise, and large sections might collapse.
The team uses a very long drill, which allows them to take samples up to 80 feet in front of the cutting head. They add extra lengths as they go. As the first samples come in, Beat assesses whether it's safe for the boring machine to continue its advance. The fate of the machine rests on his young shoulders.
For the next few meters, the rock will stay the same. We've only done 18 meters, but it will stay the same. No water. That's very important that there's hardly any water.
All clear. But even with these samples, there's no guarantee that the machine will stay safe.
You arrive in the morning and you don't know whether it will be good or bad.
Before the machine can inch forward, there are vital tasks to complete.
So we're digging this 9-meter diameter tunnel approximately in some of the hardest, most abrasive, toughest rocks in the world. And this, of course, causes a lot of wear and tear on the machine and all the equipment.
The most important maintenance task is to make sure that tomorrow the machine can cut through the rock just as quickly as today.
We have to change cutters, we have to check the cutter head for any kind of cracks. This takes us a lot of time and a lot of energy and a lot of people. There's 20 to 25 people for every machine that are working on this 6 to 8 hours every day, 7 days a week.
The maintenance shift ends, work starts up again, and the metal monster plows forward. They're making good progress. Today they'll excavate over 7,000 tons of rock. So where does all the waste go? First, it takes the 8-mile journey on conveyor belts and trains to the open air. Up here, they use some of it for construction projects, but they recycle 25% of it, turning it into a special type of concrete called shotcrete. Shotcrete is a liquid concrete solution that can be sprayed onto the tunnel walls to help strengthen them. It's tricky to prepare. In a lab, the mixture's carefully tested to produce the right consistency. 2,000 tons of this stuff is used in the tunnel every single day. When the batch has been tested, it's loaded onto special trains and sent back down the tunnels to be sprayed on the walls. You don't want to run out of shotcrete, but you don't want too much either. At his offices in Locarno, David Fabri has received a worrying phone call. There's a problem with the shotcrete, and it threatens to stop progress in a crucial section of the tunnel.
Io hanno fatto una misurazione in galleria dei profili della tratta materiale sciolto. In riva ha portato i risultati e secondo queste misurazioni ci sono sottoprofili importanti. Sottoprofili importanti.
If you're building a tunnel, you want to avoid soft or crumbling rock. But at the southern tunnel entrance, the designers had no alternative. They were forced to lay the route through this landslide.
The
problem we experienced was that as the river runs here, we couldn't enter the tunnel in this direction. We were forced to enter in this direction, which meant crossing an area made up of loose rock. It was a difficult area to enter, so we had to advance very slowly, and it cost a lot more money.
Tunneling through rock like this is dangerous, so the workers sprayed more shotcrete than usual to secure the roof. Now they found that the roof is secure, but the tunnel's too small. Too much shotcrete is as bad as too little. Down at the site, there's an emergency meeting. They have two options, and neither looks attractive. Option 1, chip away at the extra concrete. Option 2, reduce the thickness of the final tunnel lining. It all comes down to time, money, frustration. The Gotthard Tunnel is the longest, deepest transport tunnel in the world. It's 35 miles long and goes where no man has been before. But David Fabry, ace troubleshooter, has just discovered that at the edge of the possible, solutions to problems can become problems of their own. In the Gotthard Tunnel, work continues on the longest tunnel in the world. They're nearing the halfway mark, a key milestone and a crucial deadline. But one tunnel boring machine is trapped by fallen rock, and the geology up ahead looks fragile. No one's betting that they'll make it to the halfway point on time. The deadline is slipping away from them. Geologist Ronaldo Volpers has been working on the project for 14 years.
At the beginning of the construction, we found a large fault line that cuts across the site almost lengthwise.
The design team rerouted the tunnel, but they couldn't avoid the fault line completely. At the tunnel face, the geology's bad. They can't use the tunnel boring machines here because there's a good chance they'll be trapped by falling rock, like Gabby 2. The only other way to excavate a big tunnel is to use explosives. Every few days, Ronaldo and his assistant travel down to assess the rock conditions after blasting. They examine the newly exposed rock and tell the engineers and miners about the risks they face. Today, it's not looking good.
This is the worst kind of rock you can encounter in tunnel construction. It's the most difficult to dig through. This is going to slightly change our plan of advance. The explosives will be placed in the rock face according to a new plan.
Things couldn't get much worse than this. Ronaldo tells the men that the next advance will be very slow. Down here in the belly of the earth, with the exit over 3 miles away, it seems like a death wish to let off an explosion. Meet explosives expert Silvio Sangato. He sets off underground explosions every day. He starts by visiting the site to check how much liquid explosive he'll need.
Well, first we look at the rock's consistency. The harder the rock, the more explosives we put inside. And that's it.
Before setting off an explosion, Silvio dashes off to the explosive storeroom to collect the detonators. Everything is stored in a secure room and he's the only one allowed in. Down here, the rules are strict because mistakes cost lives. If you want to set off an explosion, you have to prepare the tunnel face. Enter the Jumbo. A huge mechanical octopus with 4 drilling arms. This beast can drill 4 holes at once, saving lots of time. These holes will later be pumped full of explosives, so they have to be in exactly the right place. Using a high-tech laser-guided system, the operator can line up the drilling arms with pinpoint accuracy. A new explosion may solve one problem, how to tunnel through soft rock, but it'll cause another, how to support the newly blasted space. Between the 4 boring machines, there's the soft rock fault line, where explosives have to be used. The man in charge of this section of the tunnel is Albert Schmidt, the master of the blasters. Soft rock is the curse of his life. As the mountain presses down, the support structures crumble and crack. For the past few years, Albert has been fighting a constant battle to keep the mountain from crushing the tunnel. Their first idea was to use the strongest steel they could find. It wasn't strong enough.
This was a very rigid system that we had placed in the tunnel, and you see how the forces of the mountain destroyed this beam. It's really heavy. It's certainly more than 100 kilos.
So if the mountain can crush one of the heaviest beams around, what's the answer? Albert found it far away in a factory in Germany. Since the 1850s, Bachhumer Eisenhut has been designing steel reinforcements for tunnelers, and they have the solution to Albert's problem. It's as simple as this. Instead of going strong and rigid, think flexible. Don't fight the mountain, go with it. It's a beam with moving parts held together by clamps. This beam will move with the mountain instead of breaking under its pressure. Here they test how these beams will react under the mountain's force. They put a small section of the beam under varying pressures. A rigid beam would snap, but this system collapses into itself, shrinking without buckling. Where the rock was softest, the engineers decided all the tunnel supports should be replaced with a new system. Albert's on his way to see one of the new arches being put in place. Putting up the new arches is like corralling a wild horse. It's dragged reluctantly to its new home. Before they're concreted in place, they're allowed to sit for up to 2 months as the mountain presses down, forcing the arches into their final position. These new tunnel supports are vitally necessary, but they've pushed the whole operation behind schedule. That halfway deadline next month is looking a long way off.
The more amount of anchors and the more amount of shotcrete we have to put in this supporting system costs, first of all, a lot of money, more money, and it costs also a lot of time.
Time is something that they just don't have. Albert is making sure the tunnel stays up. But sometimes the solutions to one problem can cause another problem down the line. Shotcrete, a liquid concrete solution, is sprayed to shore up the tunnel. But in the southern section, the shotcrete team overdid it, and now the tunnel's too narrow.
Questa zona è molto impegnativa.
David Fabry has to work out how to make it all fit.
We are about to enter the tunnel to investigate the section where the problem lies. Our job involves finding problems and solving them. And this can't simply be done on paper. You have to go on site and see exactly what the problem is.
Chipping away the concrete will take a lot of time, but there may be no other option.
Allora, qua non ci sono problemi, però guarda questo qua, vedi? Proprio quel punto qui sopra, si vede bene che viene fuori, quindi probabilmente quello bisogna toglierlo. Sì. Però questo qua in particolare.
Probabilmente quando finivano di unitare
hanno messo troppo.
Le ultime centinaia di litri vengono fuori sempre in modo molto irregolare.
After seeing the problem with his own eyes, David has got to come up with the answer.
Devono ancora fare e probabilmente bisognerà togliere
We'll have to get rid of this excess shotcrete.
di questo calcestruzzo di troppo. Questo si toglie con
It will be removed with a dedicated machine.
un apparecchio con una punta.
The point of the machine literally hammers away at the part that has to be removed until it comes off.
Viene praticamente spaccato via a martellate.
David realizes he has to go with option one. He'll have to chip off the concrete. He needs to get started at once if he's going to stay on schedule. On the other side of the mountain, tunnel boring machine Gabby 2 is still stuck. It's been slow going. Each blast is moving them forward by just 3 feet.
Ja, wir werden schauen, wie das Feld steht. Wenn das stabil bleibt, mache ich noch einen Abstand von 2 Metern.
Stefan can see they're going as fast as possible, but he's worried the time is slipping away. They need the machine up and running as soon as possible.
We hope that within another 3 months we will have freed up the machine. And by the end of the year, we will be able to continue as normal again.
Blasting continues, but there's a problem with one of the jumbos. It has a broken arm. More delay. The mechanic's been called, and everyone's roped in to give him a hand. One of the oil pipes is broken, and they need to cut out that section and replace it. They can't finish prepping the explosion until the machine's back up and running. But time is slipping away, so the team starts laying the detonators. After some blood, sweat, and tears, the jumbo is going again. The final holes can be drilled, and the remaining detonators can at last be laid.
We have made the connection with the electrical detonator on the circuit line.
Everyone clears the site and moves back to a safe distance.
Now he's calling to sound the firing warning in all the tunnels. When he's sounded, he gives me the signal and I fire.
Marasco, Marasco.
A posto?
Silvio is a man who really loves his work.
La sensazione come sempre.
This is the most dangerous moment in the tunnels, just after an explosion, when the rock is still loose. Huge plant vehicles are brought in to clear away the fallen rock. They work at an awe-inspiring rate, metal monsters moving quickly. Back at drilling machine Gabby 1, work continues. Over the past 2 weeks, they've advanced by a huge 1,000 feet. As the machine moves forward into the mountain, the exit gets further away and the journey to work gets a little longer. Air and water supply pipes need to be extended, and the men lay new tracks with metal sleepers for their commute to work. Today they're having problems with the cooling system. Temperatures are on the rise. Keeping the tunnel well ventilated and cool is one of the engineers' biggest problems.
With a long tunnel like this, we need a ventilation system that allows us to bring air into the tunnel up to 15 kilometers. So we got an airflow, an inbound airflow in the eastern tube and an outbound airflow in the western tube.
Rock temperatures at this depth are 113 degrees. The enormous pressure heats up the rock. Combine this with the heat produced by a huge tunnel boring machine, and you need the mother of all air conditioning units to keep you cool. And when it's not working properly, it makes work down here harder than ever. On a good day, it's 80 degrees in the tunnel, with around 70% humidity. Today, the temperature's been hitting 115, and the humidity's almost 100%. Despite today's tough conditions, the men have excavated an amazing 9,000 tons of waste material. The day shift is finished and the night shift are about to go in. Another day is over. The tunnel's a little longer, and it's time to kick back. It's still just possible that they'll make the halfway deadline next week. But the very next day, Matthias is back down the tunnels and discovers another problem. Almost halfway through the excavation of the longest and deepest tunnel in the world, the engineering teams are so close to their halfway deadline they can almost smell it. The blasting teams have been working at high pressure to stay on schedule. Boring machine Gabby 1 is still plowing on into the mountain. The work just never stops. David Fabry has found a solution to his concrete problem, but the troubleshooting never ends. Albert Schmidt is still fighting to hold the mountain up, but at last he's beginning to win his battle. Matthias Nordschwander has managed to keep his boring machine out of trouble, but there's always one more problem to solve.
I want to take a look at what this oil loss is there.
Oil leaks are common, but still taken very seriously.
We need a lot of hydraulic oil for all our equipment. Every once in a while it happens that some oil gets down to the bottom of the tunnel. The crew will absorb it with a special cellulose absorber. There's virtually no chance of a drop of oil getting out to the river.
We do a lot for the environment. This is maybe the most important environmental project Switzerland has known since the industrial era.
In Switzerland, the environment is a top priority. Its clean air and beautiful open spaces draw millions of tourists every year. The tunnel promises to cut traffic congestion and reduce pollution so that Switzerland remains as beautiful as ever. It's the last week in September and the site is a hive of activity. Preparations are being made for the open day, when the public are invited to come in and see the tunnel. But today is extra special.
Progress is fantastic. We just done 50% of the whole system with 77 kilometers. That's one more reason to have a party. We have over 10 million cubic meters of rock to excavate, and about half of that has been taken out so far. So that's a big chunk of mountain that we've taken out.
So what do the public think?
We appreciate it. We appreciate very much the courage man has to confront such enterprises. It's mind-blowing, really. Beautiful.
I think the idea is very good. The traffic jams will be reduced a great deal, especially when the heavy trucks will be off the roads and on the trains. That's very good.
The band strikes up and families take their first ever trip into the tunnels.
Right now we're over the part with the worst geology.
The stuck machine is in the process of being freed, and the machine will be free by the end of this year and start digging again by the beginning of the next year. We're still on schedule.
It is still a very long way to go.
It may be a long way to go, but today they feel like celebrating. The party's in full swing. But on the site, the work never stops. There are another 3,600 days to go and 5 million cubic tons of rock to remove before their job is done. Over the next 10 years, work will continue 24 hours a day until at last this great tunnel is complete.